This video is sponsored by Brilliant. Hey guys, I am Taufik. In this video, let's learn about subqueries in SQL. Now I'm going to start this video by explaining what subqueries are. We'll try to write a SQL query which contains a subquery, and we'll see how SQL will be processing a query statement which contains a subquery. Once you have this basic understanding, we'll then talk about the different types of subqueries in SQL. We'll try to write different types of SQL queries using these different types of subqueries. I'm also going to explain you what are the different clauses where you can use a subquery and what are the different SQL commands where we can use subqueries. Hopefully by the end of this video, you should be able to get complete understanding of what subqueries are, how to use them and where to use them. Now, before I can start, I would like to thank the sponsor of today's video, which is Brilliant. Now, Brilliant is an online learning platform where you would find interactive courses related to math, science, computer science, and many others. Now, the best part about Brilliant is that every single course that is available on their platform is designed to be interactive and visually appealing. So if you are someone who is a visual learner and prefers the interactive way of learning, where you get the option to solve different puzzles and answer different questions and solve different questions related to the concepts that you are learning, then definitely Brilliant is a platform that you should consider. Now, one more best thing about Brilliant is that you can start learning on Brilliant for free. You can just use the link that I will be providing in the description below to sign up for free and then start learning. Now, the first 200 people who will use this link will get a 20% off on your annual subscription. So definitely check that out, and thank you Brilliant for sponsoring this video. Okay, so let's start by understanding what a subquery is. Now, in the most simplest of terms, subquery is simply an SQL query which is placed inside another SQL query. Okay, now let's try to understand this better with a simple SQL query. Now, I'm going to write a simple SQL query and then I'm going to also explain you how SQL will process this statement which contains a subquery. Okay, now let's consider the employee table for this. Now, as you can see in my employee table, I have 4 different columns. So I have the employee ID, employee name, department name and salary. Now I have 24 different employee details in this table, as you can see here. Okay, now let's say you have been given a requirement where you need to find the employees whose salary is more than the average salary earned by all the employees. Okay, so basically you need to find the details of only those employees who are earning more salary than the average salary earned by all the employees in this particular table. Okay, so whenever you have a requirement to write a query, it's always better to break the query into a few parts so it kind of becomes easier to solve. Okay, now just by looking at this question, I can pretty easily say that there are 2 parts to this query. The first part is that I need to find what is the average salary earned by all the employees, because that is what is asked here, right? So first thing is I need to find the average salary. So I'm just going to write it here. Find the average salary. Okay, and then once you get the average salary, you need to then filter out the data from the employee table based on the average salary that you calculated here, right? So I can just write like filter the employees based on the above result, right? Something like this. So if I had to write a query for this, and that is if I needed to find the average salary of all the employees, I can simply write an SQL query using the aggregate function, that is average. I can say select average of salary from the employee table, right? And if I just execute this, you can see that I'm getting the average salary, and here the average salary is stated like, let me just print it here. So it's 5,791. Right? So this is the average salary. So I have basically got the average salary. The next thing that I need to do is I need to fetch only those employees whose salary is greater than this particular salary or this particular value, right? So how can I do that? So in order to do that, I can just say select star from employee, because I know all my employee details are stored in this employee table, and here I just need to add a filter. So I add a filter using the where condition, and I'm just going to say where salary is greater than, because we are looking for employees whose salary is more than the average salary, and the average salary in this case is this particular value. So I'm just going to copy and paste it here. Okay, now if I just run this, you can see that I'm getting around 12 different employees, and this is the expected output. Okay, so you can see that all the employees that I have got here are having salaries greater than 5,791. Now this query is returning the correct output, but the query itself is not actually how we are supposed to be writing SQL queries. Okay, and the simple reason for that is I'm hard coding the average value here, which is actually not correct, because in future if more employees are added to this table, then this value will change, but our query would still return the same output. Right, so that is why we need to make our query more dynamic, and how I can do that is just replacing this average salary value with the SQL query that I used here, because this is the SQL query that actually give me the average salary. So instead of printing just the value that I got from this query and then using two different queries to find my output, I can just merge them all together into one single query. So let's try to do that. So I'm just going to replace this average salary here with the query that I just wrote at the top. So let's just try to understand this query. So what I'm basically doing is I'm fetching all the employee details, and I'm just putting one filter condition saying that only fetch those employees whose salary is greater than whatever will be returned from this query. Now this query, that is this inner query, will basically return me the average salary from the employee table. Right? So if I just execute this, now you can see that I'm still getting the same output, but this is a much better way of writing a query, because I'm not hard coding the value. In future, any changes that happens to this employee table, this query itself will always fetch the correct output. Now the query that we have written here, this basically is called as an subquery. So the query that you see here, that is inside the parenthesis that I have mentioned here, this is actually called as a subquery. So this is either called a subquery, or it can also be termed as an inner query. And the outer query, that is the whole query here, is basically termed as an outer query, or it can also be called as a main query. Okay, so this is basically the most simplest example of how you can use a subquery in your select statement. Now this query is pretty easy to understand, right? So we have an inner query, which is basically a standalone SQL query on its own, because I can execute this inner query on its own. It has no dependency on any other query, right? And then the outer query here is basically using the inner query to filter the records and fetch the final result, right? So whenever SQL will come across a statement like this, how SQL will be processing this statement is, first SQL will look at this statement, it will realize that there is a subquery that has been used, and it will also realize that it can execute this subquery on its own, so it does not need to have any dependency on the outer query. So it will straight away execute this query, and whatever is returned from this query, SQL will hold it, and then it will execute the outer query, and in the outer query it will filter this salary information based on the result that is fetched from this subquery. Okay, so to sum up, the subquery itself will only be executed once, and whatever output has been returned by the subquery will be used to process the main query or the outer query. Okay, I hope this is clear, and this is basically what a subquery is and how SQL will be processing a subquery. Okay, now this is pretty simple, but there are a few different types of subqueries, and we can also use subqueries in several different ways, and that can get a little tricky. So we'll try to explain all of that in this video. Now with this basic understanding, let's look at some other type of subqueries. So basically in SQL, we have three types of subqueries. So we have scalar subquery, we have multiple row subquery, and we have correlated subqueries. Okay, let's look at each of these subqueries one by one. Let's start by looking at scalar subquery. Now scalar subquery is simply a subquery which will always return just one row and one column. Okay, now the best example for this is the query that we have just written on the top here. Now if you look at this query, this basically here is the subquery, and this subquery will always return just one record, and it only has one column, as you can see here. So it has just one column, that is the average column, and it has just one record, and it will always fetch just one record because this is an aggregate function. So whenever I am writing an SQL query which contains this kind of a subquery, this is termed as a scalar subquery. And why it is termed as a scalar subquery? Because it always returns one row and one column. Okay, now this is a good example, but then I can also rewrite the same query in several different ways, and I'll just give you one other example. So it's not mandatory that we can use a scalar subquery only in the where clause. I can also use it in maybe in a select clause or in the from clause. So let me just give you an example of how we can use it in a from clause. The same query, it will return the same output, but I'll just modify this query to use the subquery in the from clause. Okay, so what I'm just going to do is I just remove the subquery from the where clause here, and I'm just just going to join these two tables. So I'm just going to place that entire subquery here, and I'm just going to give a name for this. So that is an alias for this. I'm going to name this like average salary, and here I'll name the column like, let's say, salary, and this one I'll name it like, I'll give an alias like E, and here because I'm joining, I'll not use the where condition here, but I'll use the on clause because I'm doing an inner join here. And in my on clause, I'm just going to say e dot salary is greater than, because that is my condition, right? I just need to fetch the data for those employees where the employee salary is greater than the average salary. So I'm just going to say average underscore sal dot sal, right? So if I execute this, you can see that I'm getting the same output. Basically, I'm getting the same number of records, but I'm getting this one additional column, okay? Because since I'm doing a join and I'm using a star, it's fetching all the columns from the employee table as well as every single column that is returned from this table here. Now I'm calling this a table because whenever you're using a subquery in your join clause, that is in your from clause, then SQL kind of treats whatever is returned from that subquery as a separate table. Okay, not the actual table that we are aware of, but it's kind of SQL's way of treating that result set as a table by itself. Okay. So as you can see here, I'm trying to solve the same problem using two different queries. Now it's almost the same query, just the difference is that I'm using subquery in the where clause here in the top, and then in the second query here, I'm basically using the similar, almost the same subquery in the join condition, that is in the from clause, okay? But it's basically returning me the same output. If I exactly wanted the same number of columns, then I could just say e dot star, and even the columns would exactly match with what is written at the upper query, okay? So these are the examples for a scalar subquery. Whenever your subquery returns just one column and one row, that is a scalar subquery, and we can use scalar subquery in many different places. I just showed you example for how to use it in a where clause and how to use it in a from clause. I'm also going to show you examples for you how to use it in several different clauses, but a little later in the video. Okay, so I hope you understand this scalar subquery. Okay, I just mentioned scalary, but it's actually scalar subquery. Now let's move on to the next type of subquery that is pretty widely used, and that is multiple row subquery. Now when it comes to multiple row subquery, there are actually two types of multiple row subquery. As the name suggests, right, if a subquery will return multiple rows, then it is termed as a multiple row subquery. But there are two different types. The first type is that let's say multiple column and multiple row. Okay, basically I can just say it like subquery which returns multiple column and multiple row. Okay, so this is the first type, and then I have a second type which is basically a subquery which returns only one column and multiple rows. Okay, so both these type of subqueries, whenever we write a subquery which will return multiple columns and multiple rows, they are also termed under this type of subquery, that is multiple row subquery. And if you have a subquery which returns just one column but multiple rows, even then it is termed as a multiple row subquery. We are going to look at the example for both these type of subqueries now. Now in order to explain this, let's try to solve a problem. So let's say you have a question that has been asked by your supervisor, who is asking you to find the employees who earn the highest salary in each department. Now there are several different ways to write this query. I'll just try to write this query by using the multiple row subquery method. So just by looking at this question, it looks like I need to first find what is the highest salary in each department. So for each department, I need to find the highest salary. Once I'm able to get that, then I can compare this salary and the department information with the employee table so that I can get the final result. Okay. So let's try to write a query for that. First thing what we need to do is I need to find, so from my employee table, because all my employee information and their salary and department is available in the employee table. So I'm just going to use the same table, select employee, and I'll say, let's say I need the department name. So I'll say department name and I need the salary. Right? So I need to know what is the highest salary for each department. So whenever I have this kind of a requirement where I need to find or do some aggregation on certain column based on some unique values from a particular column, it kind of is where I should be using a group by, because I need to group the data based on each unique department name, and then under each of this group, I need to find which is the maximum salary. Right? So in order to solve this, I can just use the group by statement. I can say group by department name, And when I do a group by department name for each department, that is each unique value present in the department name column, SQL will create one group, and in that group I want to find who is having the maximum salary. So I'm just going to use the aggregate function max, and I'm going to get the maximum salary, right? So if I just execute this, you can now see that it's returning me just 4 records, because in my employee table I only have 4 different department information, and for each of this department, using the group by SQL created a group, and under that group SQL found the max salary, and that is what it is returning here. So finance has a maximum salary of 6,500, admin has 5,000, and so on and so forth. Okay, so I basically got the first part of my query. Now the next thing that I need to do is I need to use this query in order to filter the data from my employee table. So let's try to write the second part of the query. So I'm just going to say select star from employee, and here I need to add it in the filter condition. So in this particular case, when I'm adding it into the filter condition, my filter condition should consider both the columns, that is my department name as well as my salary. So in SQL, we can consider or basically compare more than one column in our filter conditions by placing multiple columns within a parenthesis. So I'm just going to say department name, comma, salary, that is a department name and salary from the employee table, and I'm just going to say equal to, or maybe I'll say in clause here, okay, because I know that this subquery is actually returning me more than one row. So if I used equal to, then SQL will expect that the right hand side will always return just one row, but if I use an in clause, then SQL will allow even if multiple values are returned from the right hand side, right? So what I'm going to do next is I'm just going to copy this query and I'm just going to place it here. Okay, so I'll just move this to the right just to make it more neat, and I think that's all. This one should work. So let's try to execute this, and then I will try to explain you this query. So if I execute this, you can now see that it's returning me 5 different records, and if I see here, it looks like in the finance department, there are 2 employees, Darwin and Satya, who are earning the same salary, that is 6,500, which was the maximum salary earned in this department. And then in HR department, Corey is earning 8,000, which is the highest salary. Then in admin, there is Monica and Dheeraj in IT department, right? So this query has returned me the output. So let's try to understand how SQL is actually processing this statement. Okay, now I have this subquery here, and as soon as SQL will execute this query, the first thing it will do is it will go and process this subquery. So this subquery has no dependency or no relation on the outer query, and I'm going to talk about the relation and the dependency on outer query in the next type of subquery. But for now, when I say no relationship, what I mean is this subquery as a whole, I can just execute it as a whole. It basically it's not going to throw me an error. And that is exactly what SQL will do. So SQL will first go and execute this subquery, and whatever is written from this subquery, it will hold that values. And then it will try to process the outer query. And for every record from the outer query, it's going to match this filter condition. So it's going to match the combination of department name and salary from the employee table with the values that is written from this subquery, that is any one of these 4 records. So if there are any records in the employee table which matches with the combination of these 4 records which are written from the subquery, and then that is what will be returned from this entire query. Okay, and that is what you see here. So this is basically what I mean when I say multiple row subquery. That is, this is a subquery which returned multiple rows, but the special thing here is that this not only returned multiple rows, but it also had multiple columns. So 2 columns in this case, it can have much more than 2 columns as well. So I hope this was clear. Now let's try to look at the other type of multiple row subquery, and that is, let's say, the single column and multiple row subquery. Okay, in order to understand this type of subquery, let's try to solve another problem. So let's say you have been given this kind of a question where you need to find the department who do not have any employees. Now in my employee table, I basically have information about all the departments and the employees that belong to this department. But then I have another table called as the department table, which basically has the information about all the departments and the location that the employees that belong to the department work at, and also their ID. Okay, now looks like if I use both the department and the employee table, I will be able to find out which are the departments which may not be present in the employee table, meaning that which are the departments where there are no employees as of now. So let me start writing this query. I know that I need information about the department, so I'm just going to say select star from department, and then I need to add some filter condition. Now my filter condition needs to be something which will eliminate all those departments who are having employees, right? So how do I find the departments where there are employees? So let me write another query here. So I'm just going to say, I'll say select star from employee, right? If I do a select star from employee, I'll get all the details of the employees, but I'm also getting all the department names here. So basically, if I do a select department name from employees, these are all the departments where they have some employees, right? Now there are a lot of duplicate records because there can be multiple employees working on the same department. So I'm just going to use a distinct here so it becomes more clear. Now if I execute this, select distinct of department name from employee, you can see that I'm getting finance, admin, IT and HR, meaning that these are the only 4 departments in the employee table, or basically these are the only 4 departments where there are some employees, right? So I'm just going to be using this subquery in my main query here, that is here, right? So what I'm just going to do is I'm just going to cut that and I'm going to have it here. So I'll place this into my subquery here. Now this is fine. This will be my whole main query or outer query, and this is going to be my subquery. But basically I also need to compare some values, right? So for that, I'm just going to say, let's say like this, in my department table, I have the department name column. So I'm just going to say if the department name is not in this whole list. So this whole list will return me only the departments where they have some employees, right? And if I just do this check where I'm just going to say from the department table, find only those departments who are not in this list, then I should be able to get the departments which are basically not having any employees. So if I execute this, you can see that I'm getting only 2 departments, that is marketing and sales. These are the 2 departments who currently do not have any employees. So this particular query here is a good example for a single column multi-row subquery. And why I'm saying that is the subquery that I'm using in this query here, if I just execute it as a whole, you can just see that it's returning me multiple rows, but it's only returning me 1 column. Okay, and that is exactly what I meant by saying this single column multiple row. If your subquery returns multiple column and multiple row, it's also called as a multiple row subquery, but it kind of will return multiple values. So you need to have multiple columns on the left hand side to compare with it. And you can also use this multiple row subqueries in the from clause. Maybe I'll try to show it a little later, but yes, you can use it in multiple different places as well. This is just one example. And then single row, or basically a single column multiple row subquery would be something like this, where multiple rows are returned with just 1 column, and you can just compare it with any column in your main query or outer query. Okay, so this is basically all about the second type of subqueries, that is multiple row subqueries. Now let's look at the third type of subquery, which is correlated subquery. Now I think correlated subquery is something that many of you guys have requested me to make a video on. So this looks like something that is slightly tricky to understand, because the processing of a correlated subquery by SQL is slightly different with regards to how SQL executes or basically processes a statement which contains either a scalar or multiple row subquery. Okay, so let's try to understand that. Now what exactly is a correlated subquery? Just by the name, it's very clear, right? It's a subquery which is related to the outer query. So basically the processing of your subquery depends on the values that are returned from the outer query. Okay, now the 2 types of subqueries that we saw, the scalar subquery and the multiple row subquery, I could execute these subqueries by itself. I did not need to execute the whole query to execute the subquery, because the subquery were not dependent on any other query, right? That is how scalar subquery and multiple row subqueries work. So when SQL processes a statement which contains a scalar or a multiple row subquery, SQL will just execute the subquery first, and it will execute the subquery just once, right? Because once the SQL will execute the subquery, the data is available, or the output is available for SQL to use it to process every record from the outer query. But when it comes to a correlated subquery, it's going to be slightly different. Okay, so let's try to understand this better by trying to solve a particular question. So before that, I'm just going to write it here. Subquery which is related to the outer query. Okay, so this is the most simplest definition that I can give for a correlated subquery. Now let's try to solve this particular question. So let's say you have been asked to write a query to find the employees in each department who earn more than the average salary in that department. Okay, now this question is slightly different from the question that we solved in the beginning. In the first question, I think what we saw in this video was that we need to find the employees whose salary was greater than the average salary earned by all the employees, and we easily could do that by using the Scalar subquery. But the question that we have now is that we need to find the employees in each department whose salary is greater than the average salary in that department. So we need to find the average salary specific to the department that employee belongs to, and then compare his salary with that average salary of that department. Okay, so whenever you have this kind of a requirement, we can use a correlated subquery. Of course, one thing I would like to say is that every single SQL query can be solved in so many different ways. So it does not mean one is right and one is wrong. In this particular case, I'm just trying to explain you how a correlated subquery works. Okay, so let's try to solve this subquery. So I'm just going to almost follow the same approach that we did in the beginning. So first thing is we need to find the average salary, right? So in order to find the average salary, I'm just going to say average of salary from the employee table, and that should be fine. But there is one additional check that I need to do here, and that is I need to find the average salary with respect to each department. So whenever I have this kind of check or a condition, it means that I need to have some filter condition to check for each specific department, right? So I can just say department name equal to, I need to do something, right? I need to find for each specific department, okay? Or let's say specific department, something like this. Okay, let's just hold on this one. We'll try to find it a little later. Okay, now of course someone might think that we can also solve this by using group by. Of course we can, and we can solve it in maybe 10 different ways as well, but for now let's try to solve it using a correlated subquery. Okay, so my question here states that I need to find only those employees whose salary is greater than the average salary with respect to their department, right? So let's try to write the query, that is the outer query. So I'm just going to say select star from employee, right? And here I just need to put my filter condition. I'm going to say where salary is greater than, because I need to find only those employees whose salary is greater than the average salary in that department. Now, how do I find the average salary in that department? So I'll just copy this whole subquery here, and I'm just going to place it here. So I'll just make it more neater just by putting it here, and I'll move the where clause here, and yeah, okay. So what basically I'm doing is I'm fetching all the employee details, and I'm putting a filter condition where salary is greater than the average salary. Now, if I did not have this where condition, that is if I just comment out this thing, and if I executed this will still work fine, and it will return me all the records. But this would be the query which would basically give me the output for only those employees whose salary is greater than the average salary of all the employees, because you can see here I'm finding the average salary of all the employees from that table. Okay, and based on that average salary of the entire employees or entire company, this filter condition will work. But this is not the requirement that we have now. We need to find the average salary specific to the department that the current employee that I'm trying to process in this query, right? So for that, I can put a condition like this where I just say department name equal to, so I'm going to give an alias here. I'm going to say like this is my E2, and let's say this will be my E1. Okay, so I'm just going to say E2 dot, and here I'll say E1 dot department name. Okay, so before I execute this, let's try to understand what I'm trying to do here. This employee table has 24 employee details, right, or 24 records. For every record, what it will happen is this subquery will get executed. Okay, so in this particular case, when SQL will try to process this statement, SQL will come and see that there is a subquery. It will try to execute the subquery, but then it will not be able to execute the subquery, because if I execute this, you can see it's going to throw me an error, because I'm referring to a column in this subquery which is coming from my outer query. Okay, and this is why it is called as a correlated subquery, because this subquery here is related or basically dependent on some of the values from the outer query. Okay, so SQL will not be able to process this subquery in the beginning, because this subquery is dependent on every single value that will be returned from the outer query. So how SQL is going to process this particular statement is, it's going to execute the outer query, and for every single record that is processed from the outer query, it will execute the inner query. So meaning that since this outer query in this particular case will be returning me 24 records, or basically has 24 records, this subquery in this case will get executed 24 different times. Okay, so every one time for every single record from the employee table. Okay, and for every single record from the employee table, if I see here, right, it will first execute this query for this statement, that is the employee ID 1001, department name, that is admin. So this admin will get replaced here because E1 is my outer query table. So E1 dot department name in the first record would be admin. So it will check department name equal to admin from the employee table. So this is like another copy of the employee table that I'm using here. And if it finds a record, in this case, it will find a record for the employee department. It's going to find the average salary. So it is not going to find average salary for the entire employee table. It's going to find the average salary only for the employees who belong to the admin department. Okay, so once it finds the average salary from the admin department, it will try to do this comparison with the salary from this first record. And if there is a success, or basically if the salary from this employee is greater than the average salary that is written from here, then this record will get returned as the final output. Okay, so if I just execute this query here, you can now see that I'm getting 12 records, and these are the only employees whose salary is greater than the average salary with respect to their department. Now, if you're not very clear about this, hold on, I'll try to explain this further, and I'm also going to show you another query which should hopefully explain you what correlated subqueries are. Now, just to explain you again how SQL is going to process this query is, or basically this statement is, for every single employee, SQL will process this subquery once. Okay, so and when I say once, it's basically going to fetch this department name from the outer query. So for every department name from the outer query, this subquery will get executed. And so in this particular case, I can see that I have admin. I think there are 4 different employees belonging to the admin department in this table. So there will be 4 times when this department name, that is E1 dot department name, would be admin, and basically it would kind of calculate the average salary. You would say that it's basically doing the same thing again, and that is a problem with correlated subquery, because when you have a correlated subquery, and if your outer query is going to process, let's say, millions of records, then your subquery is going to get processed millions of times. And that is the reason why many times we prefer not to use a correlated subquery. So if we can solve a problem by using joins, or just by using a scalar or a multi-row subquery, we'll prefer to use that rather than using correlated subquery. But there are cases where you cannot avoid using a correlated subquery, and correlated subqueries are very, very useful. There are cases where using a correlated subquery, you can solve the most complex problems pretty easily. Okay, so even though it might process your subquery multiple different times, it will still be very useful in many different cases. Okay, so in the most simplest of terms, for every record from the outer query, the subquery gets executed. That is, this is the correlated subquery, and the correlated subquery execution depends on the value that is returned from the outer query, and in this case, that value is coming from this department name column. Okay, so this is basically how I have solved this question. Okay, now let me use another example to help you understand what a correlated subquery is. So let's say we have a question like this. This is basically the question that we solved using, I think, multi-row subquery just a few minutes back. But let's try to solve this question using a correlated subquery. Okay, because this is the kind of question that we generally use correlated subquery very frequently. Okay, so let's say you have a requirement where you are asked to find the departments who do not have any employees. Okay, so how do I solve this? So I need to find the departments. I know that, so I can just say select star from department, because my final output needs to be some details of the department. So I'm just going to say select star from department, but I need to filter out those departments who are having employees, right? So what I can do is I can use an operator called as not exist. Okay, and here I can write a subquery. Okay, in this case, I'm going to use a correlated subquery. So I'm just going to say select star from, let's say, the employee table. Okay, and just going to say where, and let's say I'll say this alias as E and this alias as D, and I'll say E dot department name equal to D dot department name. Okay, now what exactly I'm doing here is I'm fetching all the details from the department table, but I am eliminating some records by using this not exist. What this not exist will do is, if from this subquery, if this will return no records for every single record that is processed from this statement or from this outer query, where this subquery will not return any record, then this statement, this not exist, will hold true, and that particular record will be returned as part of my final output. In other words, if I just see what is the data in the department table, and let's say it's going to start processing from the first record, and in my first record you can see that I have the department name as admin. So I have this d dot department name will be admin, so this will be admin. So let's say in my select, in my employee table, if I just copy this whole thing here just to give you an example, okay, and let's say if I replace this with admin, and if I run this, you can see that it's returning me some records. Okay, now here I have put 1. It does not matter what you put. I can put a column name here or any constant value, whatever, does not matter. Just that it should return some column, okay, whenever I'm using exist and not exist. Now what happens when I am processing a record from the department table when the department is admin, this particular subquery will return me some records, right? Since this subquery will return me some records, this not exist will become false. So whatever record is being processed, it will not be considered for final output. But let's say similarly after processing second, third, fourth, it will try to process this record where the department name is marketing, right? So when I write this marketing and if I execute this, you can see that it's returning me no records. So when this subquery will return no records, this not exist clause will hold true. That means it becomes true, and whatever record it was processing in this case will be returned as part of my final output. Okay, so if I execute this whole query here, you can see that it's only returning me the records marketing and sales, because these are the only two departments which are not present in the employee table. So only for these two departments this particular subquery here will not return any records, and that is why not exist will become true, and that is why those two records will be returned as part of my final output. So this is also an example for using correlated subquery, and this is kind of the place where we use correlated subqueries a lot whenever we need to check if a record exists in one table or the other table, or if the record is not exist or something like that, right? When we need to compare the data between two different queries or two different tables, we kind of use this correlated subqueries, because for every record from the outer query we can check for corresponding record in the subquery, and if the subquery does not return any record, then it means that that record is not present in the table we are using in the subquery. Okay, so this is basically what a correlated subquery is. I hope you get some understanding. The biggest difference between correlated subquery and all other type of subqueries are that all the other type of subqueries, SQL will straight away execute the subquery. It will keep or hold that output and then use that output from the subquery to process the outer query. But when it comes to correlated subquery, SQL will not be able to execute the subquery as a whole. So for every single record that is processed from the outer query, the subquery, that is a correlated subquery, will be executed. So depending on how many records the outer query will process, that many number of times the correlated subquery will get executed, because the correlated subquery will have some join condition based on some of the column that is used from the outer query. So you can kind of say that correlated subquery would be a little slow, because it will get processed multiple different times based on the number of records processed in the outer query. But there are many scenarios where we have to use correlated subquery to solve our problems. Okay, so I hope this is clear. Now let's move on to the next one. Now, basically, these are all the types of subqueries that we have in SQL: scalar, multiple row subqueries, and correlated subqueries. But then we can also have SQL queries where we have a subquery inside a subquery inside a subquery, kind of like a nested subquery. But in general, nested subquery is also a subquery, so we can also call a subquery as a nested subquery. But I just wanted to show you an example of an SQL query where we would have like a nested subqueries, or like a subquery inside a subquery inside a subquery. Okay, so let's try to understand that. And to understand this, let's try to solve this particular question. Okay, so for this question, I will need to use another table, and another table that I have is the sales table. So if I check this table, you can see that this table has, I think, around 11 different records. It's basically information about some store. So I have the store ID, I have the store name, and let's say these are all the Apple store. Okay, and then I have the product name. So these are all the Apple products, like their phone, their laptop, etc. Then the quantity, number of units that have been sold, and the price. So this is basically my sales table. Now we are going to use this sales table to solve this particular problem. Okay, now the problem that, let's say, you have been given is to find the stores whose sales were better than the average sales across all the stores. Okay, so let's try to understand this. We need to find the stores whose sales are better than the average sales across all the stores. Now, in order to solve this problem, let's try to break this into a few parts. So what is the first thing that we need to find? We need to find the total sales for each store. This is my first thing, right? Once I get the total sales for each store, I can then find the, let's say, average sales for all the stores, right? And once I have this average stores, I can then just compare 1 and 2 to get my final output, right? Now, the first thing here, that is to find the total sales for each store. Why do I need to do this is because you can see in this table for the same store, I have multiple records here. So you can see for Apple Store 1, you can see I have 3 different records here, and if I just count the price, that is 1000, 6000 and 500, that is 7500, this would be the total sales that this Apple Store 1 has done, and similarly for other stores, right? So I cannot just sum up all the data from this table. The first thing is I need to segregate the data based on each store, and then I need to find the total sale value, and then over that I need to find the average sales for all the stores. Okay, there are a few things that we need to do here. So let's try to do the first step here. How do I do the first step? So I'm just going to say select from sales. And here, in order to find the total sales, that is the total price for each store, I can just group the data together. So I'm just going to say group by, I'll say store name, and I'm just going to use the same store name in my select clause here, and then I'm going to do a sum of price, right? And this one I'm going to name it like, let's say, total sales, right? So if I just execute this, you can now see that I'm getting one record for each store, and it's returning me the total sales that has been done by each of this store. So I think I have got the first part of this query. Now the second part of this query I need to do is I need to find the average sales for all the stores. How do I find the average sales for all the stores? I can do that by summing up all of this amount and then dividing by number of stores, right? But I need to do this average on this particular data, not on all the data from the sales table, because there I have multiple records for the same store, and that would not be correct. I need to sum the total data that I have got from this query. So basically, on the output that is written from this query, I need to find my average, right? So what I will do is I'll just use this query itself. So I'm just going to say select from, and here I'll just move this right. And let's say I'm just going to use this as a subquery here. Okay, so I'll just move this to the right. I'll close this, and here I'll just say average of, okay, this particular column, that is total sales, right? And okay, so I think, okay, and I'll give an alias here, and I think this should pretty well work. And yes, I'm getting the average sales, right? So I have got the average sales for all the stores by using both of this query. And now my third part of this query is to compare 1 and 2. Now my 1 is this, and my 2 is the combination of these two. So in order to do this comparison, I'll basically need to reuse this one more time, right? So what I'm just going to do is I'm going to write a query. So let's say select from, and my first part of this query was this one where I found the total sales for each store, and I'm going to place this inside the parenthesis as a subquery. I'm going to give a name for this, like let's say sales, and then I'm going to do a join, and I'll join it with this whole query here. So I'm just going to move this to the right, and let's say I'm going to name this whole thing like average sales. Okay, and here I'll give an alias for this, like let's say sales. Okay, and then finally I'm going to join these two tables by using the on clause, and my on clause is going to join based on sales dot total sales. So my requirement here is I need to find whose sales were better than the average sales. So if it should be better than the average sales, then I need to put a greater than symbol here, and then I'm going to say average underscore sales dot sales, right? So, and here let's say I'm just going to do a star, and now if I execute this query, okay, I'm getting an error. I think, yeah, I missed a parenthesis here. So let's add a parenthesis. Okay, I think should be fine now. So let's run. Okay, so now I'm getting the output, and you can see that there are only two stores, that is the Apple Store 3 and Apple Store 1, whose total sales are greater than the average sales. So I have 9,700 and 7,500, and average sales are 6,050. So if I just execute this inner query here, just to see what were the total sales from all the stores, you can see that I have 9,700. So this Apple Store 2 only had 2,000 of sales, and the Apple Store 4 had 5,000, whereas the average sales that we got was around 6,050, right? So only two records actually satisfied our condition, and that is why this whole query is returning only 2 records. Now this is fine, and the one thing that you need to focus here is I have this outer query, inside that I have this subquery, and then I'm joining it with another subquery, but this another subquery, this second subquery here again has another subquery used here. So I have a subquery inside another subquery inside another subquery. Okay, so this is just an example that I wanted to show you how you can write SQL queries where you have multiple different subqueries nested one after the other. Okay, now there's one last thing that I want to tell you about this query, and that is this is actually not the best way of writing this query, and the simple reason for that is if you look at this subquery here, this subquery is basically repeated here, and the same thing is again repeated here. So always remember, whenever you're writing a SQL statement, and if you're using a subquery, and if you're using the same subquery multiple times in your query, then it's a perfect occasion for you to use with clause. Okay, so let me try to modify this query by using the with clause. I'm just going to say with, and what I'll do is I'll just copy this whole thing here. Okay, this whole the sales subqueries. I'm just going to name it like with sales as, and I'm going to place it here. Okay, and then I'll write my main query here, and I'm going to say from, and basically going to copy the same from clause. Okay, so I'm just going to copy the same from clause, but I'll do some small changes. So I'll just remove this. Okay, first change that I'll do is, since I'm using this subquery as inside my with clause and I'm calling it like sales, I'm just going to replace this subquery everywhere in my query with that name, that is sales. Okay, so similarly I'm using the same subquery here, so I'm just going to call it like sales. And I think that's all. So what I have done is the subquery that I was using multiple times, so I was using it here and I was using it here, what I did was I just removed that from there and I put it inside the with clause. I gave a name for that like sales, and everywhere wherever I wanted to access that subquery, I'll just use this name that I have given in my with clause. Okay, that is here sales and here as sales. And now if I execute this, the output should still be the same. Okay, it's not showing the output because I did not put anything in the select clause. So I put a star here now, and now if I run this, now you can see it's returning me the basically the same output that was returned from the above subquery. So this was just an example of how you can use nested subqueries and how you can replace multiple different subqueries, or basically the same query which is used multiple times in your query, by using a with clause. This is a much better way of writing an SQL statement. Okay, I hope all of this was clear. You have understood all of these concepts. Now, I just want to explain you what are the different clauses in SQL where you can use a subquery. Now, to answer you straight away, there are 4 clauses in SQL where you can use a subquery. So the first one is we can use a subquery in select, right? And we can use a subquery in from, and we can use a subquery in the where clause, and we can also use a subquery in the having clause. So I think I have already shown you queries where we have used the subquery in the from clause and the where clause. So you can see that just this previous query here, I have used this subquery in my from clause. So this is definitely example for using a subquery in your from clause. Now when it comes to the where clause, I think we have shown you some examples. So you can see that this is one example of where we can use a subquery in the where clause, right? But I think I have not shown you example of how to use a subquery in the select clause and in the having clause. So let's try to understand that. Okay, so first let's see using a subquery in select clause. Okay, now this is actually not recommended. It's always better that you do not use a subquery in the select clause, but I still want to show you how you can do that, and how I'll also give you an alternative way of how to achieve the same result without using the subquery in a select clause. Okay, so let's try to understand this with another problem. So let's say you have been given this question where you have been asked to fetch all the employee details and add remarks to only those employees who earn more than the average pay. So basically you need to fetch all the employee details. So you are basically not asked to filter any records, but for every single employee that you will be fetching, you need to display some remarks column, and in the remarks column you need to mention if that employee is earning more than the average salary for all the employees. Okay, so let's see how we can write this query. Now I know that I don't need to do any filter, so I can just fetch all the details from the employee tables. I'm just going to say select star from employee, and this will fetch me all the 24 employees from this table. Now this is fine. The additional thing that I need to do is I need to have a remarks column. Okay, now I'm just going to add a parenthesis and I'm going to call this like remarks. So this is my column where I need to add a remark saying that this employee is earning more than the average pay. And how do I do that? So I can just write an SQL query here itself. So let's see how I can do that. So I'm just going to say, okay, but because I need to display this remark only for those employees who are earning more than the average pay and not for all the employees, whenever I have this kind of a conditional statement, what I can do is I can add a case statement. So what I'm going to do is I'm going to say case when, and let's say I'm going to say salary. Okay, this is from the employee table is greater than, and here I'll pass my subquery. So my subquery would be something like select average of salary from, let's say again, the employee table, because my salary is present in the employee table. And I think that's all. And yeah, so I'm basically comparing the salary for every record from the employee table with the average salary that I will get from this subquery here. Okay, so this is basically a scalar subquery. Now this is a condition when you're using a subquery in a select clause. It has to return just one record and one column. If it returns more than one column, or if it returns more than one row, then it's going to throw an error. Okay, so here I'm just going to say if salary is greater than the average salary, then I'm going to print like higher than average. Okay, and else, let's say if it is any other employees, then I'm just going to print like, let's say null. Okay, and I'm going to do an end case here, and I think that should be good enough. Okay, so if I execute this query, you can see that I'm still getting 24 records, but there's a new column added here at the end, and this column, you can see that it's null for any employees whose salary is less than average salary, but for any employees who's earning more than the average salary, you can see it's printing like higher than average. Okay, so it's printing higher than average, etc. Okay, now this is basically an example I wanted to show you of how you can use a select clause in your SQL query, basically how you can use a subquery inside your select clause. Now trust me, whenever you have this kind of a requirement, you can always find alternative ways to remove the select clause, or basically to remove the subquery from your select clause. This is not the best method of writing a query, simply because if you write a select query inside your select clause, then for every single record your query will process, this whole SQL query that you have mentioned in your select clause will also get processed, and you can easily replace this subquery by putting it inside your join condition. Okay, so always try to avoid using a select query inside your select clause or a subquery inside your select clause, because you can easily put that inside your join condition. Okay, so let's say for this, if I had to basically remodify this query such that I remove the select clause from here. So let's say I remove the select clause from here and put it inside the join condition. So I'm just going to say, I'll move it here. I'll say join with this whole subquery. I'm going to name this like, let's say average salary, and here this column as, let's say salary. Okay, and since I do not have any join conditions here and I need to fetch all the records from the employee table, I'm just going to do a cross join here. Okay, and here I'll say average underscore salary dot sal. And so basically what I'm doing is I use that subquery in my from clause. I gave an alias for that, and then I'm just using that alias and that column from that subquery, right? And that's all. Now if I execute this, you can see that I'm still getting 24 records, and I'm still getting basically the exact same output that I got from the above query. Okay, so I have just replaced the same query here that you can see, where I was using the subquery in the select clause, by just using that exact subquery in my from clause. Okay, so this is a much better way of writing a query rather than using a select query or a subquery in your select clause. Okay, but I still wanted to show you how you can do this. Okay, hopefully this is clear. Now let's see how we can write a select query using in the having clause. Okay, and this can actually be pretty useful in certain cases. So let's try to understand this by solving a problem. So let's say you have been given this question to solve, and you have been asked to find the stores who have sold more units than the average units sold by all the stores. So basically we need to find the stores who have sold more units than the average units sold by all the stores. So let's try to write this query by using a subquery in our having clause. Okay, now I know that my stores information is present in my table sales, right? So I'm just going to say select star from sales, and if I execute this, you can see I'm getting all of this data. I need to find for each store how many units they have sold. So whenever I have to do this kind of aggregation based on each specific store, I can just use a group by. So I'm just going to say store name comma, and I know that the column that I need to use here is quantity, because this is basically the column which is going to tell me the number of units that have been sold. And here I'm going to use a group by, so I'm just going to say group by the store name, and I need to group the data based on store name, and I need to find the total quantity or total number of items that they have sold. And you can see I have multiple records here for the same store, and I need to sum these quantities together to identify how many units have been sold totally by a particular store. So for that I can use the aggregate function as sum, and I think this should be pretty okay. If I execute this, you can see that I'm getting the store 3, Apple Store 3 has sold 11 units, store 2 has sold 2 units, and so on and so forth. Okay, but this is basically all the units that have been sold by each store. So this is just one part of the query. The next thing that we need to do is we need to only fetch those records, or basically those stores who have sold more units than the average units sold by all the stores. So how do I find the average units sold by all the stores? I can just find the average units sold by all the stores just by using the average aggregate function. So I'm just going to say average quantity of this one from sales, right? If I execute this, you can see I'm getting it like 2. So I can just use this subquery somewhere in my outer query. So let's see where I can use that. Since I'm using a group by already in my query here, I can use a having clause here, and in my having clause I can basically compare this value, because this is the total quantity or items that have been sold by each store, right? So I'm just going to copy that same thing here. I'm going to say quantity, and I'm going to compare this, okay, with the subquery that we just wrote. So again, if I just have to explain, this is basically giving me the average units that have been sold by each store, and my group by query here was returning me the total items that have been sold by each store. Okay, and then this total items that I have, that I got from the sum of quantity, I'm just checking if it is greater than the average units that have been sold, then only fetch those records. So now if I run this, currently there are 4 records, and if I run this entire query, you can see there is only 3, because Apple Store 3, Apple Store 1 and Apple Store 4 are the only stores who have sold more than 2 units in their store. Okay, and that 2 is basically the average unit sold by each store, right? So this is basically how I have solved this query, and you can see that I have used a subquery here inside my having clause. Okay, so I hope this was clear how you can use a subquery in your having clause as well. Now let's move on to the last part of this video. I know that this video is pretty long, and I really didn't want to make it very long, but there were so many different things that I wanted to explain about subqueries that I had to be long. Okay, now the last part that I want to cover in this video is going to be all the different SQL commands where we can use subqueries. Now we have seen subqueries in the select queries, basically in the select statement. We have seen all of these examples where we used subqueries in the select statement, but we can also use subqueries in some other SQL commands, and they are, we can use it in insert, okay, and we can use it in update, and I can also use it in delete. Okay, so other than select, so if I just say SQL or SQL query, right? So basically these are the 4 statements where we can use a subquery, right? So we have already seen all of this, so this is done, and now let's see how we can use a subquery in these 3 statements. Okay, so let's start by looking at insert. Okay, so let's say you have a requirement where you need to insert data to an history table, that is the employee history table. Okay, so all the employee information, you need to store it in the employee history table, and we should make sure that we do not insert any duplicate records. So once the employee information has been stored in the employee history table, once again we should not be storing the same employee information in the history table. Okay, so let's say you have this kind of a requirement where we always have some history table in our projects, right? And how do we basically populate the history table? Okay, so let's see how we can do that. Now for this, I already have created a table, and that is the employee history table. So I'm just going to show you that employee history, and currently this table is blank. There is no data in this table as of now. Now my requirement is that I need to store the employee information in this history table, right? So this means that the information is already present in some other table. So I think this table requires the employee ID, name, department name, salary, and location. Looks like these information are available in the employee and the department table. So I just need to refer to the employee and the department table and fetch the data from those two tables and then load it into this history table, right? I don't need to write insert script for each and every record because this data is already available in some other tables already in our database. So whenever you have this kind of a requirement where you need to populate a third table or like let's say some other table, but based on the data available from some existing tables, then this is where we will need to use some subquery or basically an SQL query to load data into this new table. Okay, so let's see how we can do this. So I can just write my insert command, insert into this table name, that is the employee history, right? And then here I can just write my select query. Okay, so I'm just going to say select from the employee table because I know most of the details are coming from the employee table. I need to join it with the department table because I need to fetch the location. As you can see here, I have the location column that I need. I'm just going to give an alias for department like D, and I'm going to join it based on D dot department name equal to E dot department name. And okay, I think this is fine. Now let me put all the different columns. I'm going to specify E dot employee ID, comma E dot EMP name, comma D dot department name, comma E dot salary, comma D dot location. I think these are all the columns that we need, and these are the exact columns that are present in the employee history table. So that should be fine. Now there is one check that I need to do here, and that is I should only insert an employee detail just once in the history table. So if the employee information is already present in the history table, then I should not be inserting it again. Okay. Now in order to add this kind of a check, I can add a where condition here, and here I can just use my not exist clause, and here I'll just put a query here saying that I'll write a subquery here, that is the correlated subquery, and I'm just going to say select one from, let's say, employee history table. Okay, and I'm going to call this like EH, and I'm going to say EH.EMP ID equal to E.EMP ID. Okay, now if I had to explain this query, what exactly I'm doing is, now I think this is pretty self-explanatory, where I'm just joining the employee table with department table. I'm fetching all the columns that I need for my history table, and I'm joining these two tables using the department name. Now that is fine. But the problem is, if I did not have this where condition, then if I executed this query multiple times, then the same employee details would get inserted into the history table. Let's assume that the history table does not have any primary key or any constraints. Okay, so duplicate data also might get inserted. So how do we eliminate that? And that one I can do that by this where condition. What this where condition is doing is, it's checking, or basically it's only going to insert those records which are not existing in the employee history table. Okay, so this not exist will check if this data here or this subquery here is going to return any value. So this subquery here, I'm basically querying from the employee history table. For every employee ID that I'm getting from this query here, this outer query here, I'm checking for that employee ID in the employee history table. And if the employee already present in the employee history table, then this subquery is going to return me some records, right? And as soon as it returns some records, this not exist will fail, and hence this whole query would not return any record. Okay, but let's say this outer query will return an employee which is not present in the employee history table, then this query here would not return any record because employee history does not have that employee. So since this subquery is not returning any record, this not exist would be true, hence this whole query would return some data, and that is what would get inserted into the employee history. Okay, so that is basically what I'm doing. Now let me try to execute this, and you can see that it's inserted 24 records. Okay, and now let's say if I execute this again, I'll execute this again. Okay, and now you can see it's inserting 0 records. Why? Those 24 have already been inserted into the employee history, and because of this where condition, it's not going to fetch those 24 records again. Okay, so this is basically how we can see in the data in employee history. Now we can see there are 24 records, and it has all the location information as well. Okay, so this is basically how we can use a subquery to load data into a table using the insert command. Okay, or basically how we can use a subquery in the insert command. Now let's move on to the next one, and that is the update command. So I'm just going to say update, and let's understand this update again by looking at a question. Let's try to solve that. So let's say you have been given a requirement to increment, or basically you need to give 10% increment to all the employees in the Bangalore location. So only in the Bangalore location, based on the maximum salary earned by an employee in each department. So What is the increment that you need to give? You need to find the maximum salary in each department and then give a 10% hike on that maximum salary. Okay. And then you need to give this increment only to those employees who are working in the Bangalore location. Okay. And then you need to only consider employees in the history table who are available in the employee history table. Okay. So if there are any employees who are available in the employee table but not available in the employee history table, then those should be ignored. Okay, so there are a few checks we need to do. Now let's try to do this by an update statement. So we know that when we need to update a table, we first need to say update that table name. So I'm just going to say update table name E, and then I need to use my set command, and then I need to use my where command. Okay, now inside my set command, so let's try to write this. Okay, I know that I need to update the salary, so I'm just going to say salary equal to, and here I need to add a subquery. Okay, why I need a subquery here is because the value with which I want to update this column is dependent on a few things. So I need to find out the maximum salary for each department, and then over that I need to give a 10% hike, right? So let's try to write that. I'm going to say select. Okay, and here I'm going to say select from the employee table, because in order to find the maximum salary earned by each employee in the department, I again need to use the employee table. And instead of using the employee table, I'll use the employee history table, because I know that I only need to update data or employees who are present in the employee history table. So I'm just going to use the employee history table itself, and I'm going to give an alias for this, like let's say EH. And how I'm going to join this is I'm just going to say EH dot department name equal to E dot department name. So kind of I'm creating a correlated subquery here. So this subquery will be dependent on the outer query, that is this employee table. Now you might think that this is not an outer query. So it's not like we call just the select statement as an outer query. Even this update statement is basically an outer query, okay, for SQL. So this will kind of become my subquery. So for every department, it's going to find the maximum salary. So I'm just going to say max of salary, and then I need to sum it with a 10% hike on this salary, right? So how do I find a 10% of a salary? Just by using simple mathematics. I'm just going to multiply this by 0.1. I'll put this entire thing inside the parentheses here, so it does not get messed up. So this is my salary, and then this is just 10% of that salary, right? So this will basically be like, yeah, it's going to be the 10% over the maximum salary that is returned from this table, right? So this is what we are doing. I hope this is clear. We are just using a correlated subquery for every department from this employee table. I'm going to find the maximum salary by referring to the employee history table, and then over that I'm giving 10% hike and I'm summing them together, right? Now what are my filter condition? My first filter condition is that I need to only give this hike to those employees who are working in the Bangalore location. Now I know that this location information is only present in the department table, right? So what I'm just going to do is I'm going to say E dot department name, okay, in select department name, and maybe I'll just say from department, and okay, maybe I'll just move this to the same line here, okay, and here I'll just say where location equal to Bangalore. Okay, so this is basically my where condition, or maybe I'll just move this to the next line so just it becomes more clear. And this is not the only filter condition that I need to apply, because I have another filter condition which says only consider employees in the employee history table, right? So what I need to do is I just need to add another check where I'm just going to say e.employee ID in, and I'm going to say select employee ID from the employee history table, right? So I think that's all. So if I execute this now, and you can see that it's updated 20 records. Okay, so out of the 24 employees, looks like only 20 employees satisfied this condition, and that is what is updated. Okay, so this is basically how I can use an subquery in a update statement. Now you can see that I have used a subquery in the set clause, as well as I have used the subquery in the where clause. So you can use a subquery in the set as well as in the where clause in an update statement. It's not mandatory that you need to use in both the places. Any one place also you can use. But this is basically how you can use a subquery. Okay. Now, if you think that this is not a subquery, this is just one query, it's not the case, because this outer update statement is basically treated like an outer query, and this inside select statement is treated like a subquery. Okay. In this case, I'm using a correlated subquery here, and then here, I think this is going to be just what is it exactly? Okay, this is like a multi-row subquery, but a single column multi-row subquery. Okay, so I hope this is clear. Now let's move on to the last part of this video, and that is how to write subqueries using in the delete statement. Okay, so let's try to understand this again by solving a particular problem. And the problem that we are going to solve this time is going to be this, that is, let's say you have been given a requirement to delete all the departments who do not have any employees. So I need to delete the departments who do not have any employees. Now I can just use the command like delete from department where department name in something, right? Now this something is basically the departments which do not have any employees. Now I think already in the previous statement, I think when we were looking at correlated subquery, I wrote this query here and I'm just copying and pasting them here. So this was the statement or the query that we wrote. Basically what we were doing is we were using a correlated subquery to find out the departments who are not having any employees. Right, this one I already explained above, so I'm not going to explain it here again, but this time instead of fetching all the columns from the department table, I'm just going to fetch the department name. Okay, so if I execute this, you can see that it's fetching me these two departments, and these two are the only departments which do not have any employees. So I'm just going to use this same query here. So I'm just going to cut this and I'm going to place it here. Okay, so if I just move this to the right, and let's say if I just make it more neat, so there are subqueries inside a subquery in this particular case, but that's fine. So I think that's all. So this subquery here is going to return me the two departments who do not have any employees. And once I get these two departments, I'm just going to delete the data from the department table which belongs to these two departments that I got from this correlated subquery here. Okay, so if I execute this, it should delete two records, and that is what it has done. Okay, so this is how you can use a subquery in your delete statement. Okay, so I think finally we are done with this video. I think it was a pretty long video, but I really wanted to cover everything about subqueries in a single video. I hope you found some value from this video. If you did, then please make sure to give me a thumbs up on this video. And also if you have not subscribed, make sure to subscribe to the channel. Also leave your feedback in the comments below, because I really like reading those comments. It kind of makes me understand what I'm doing, whether I'm doing the right thing or doing something wrong. Kind of helps me to improve. Thank you guys, and see you soon in the next one. Bye.